PARCA Clinical Section 5.3 covers speech recognition, immediate reporting, batch reporting, transcriptionist reporting, handheld dictation microphones, structured reports macros, critical results reporting, discrepancy reporting, and peer reviews. Speech recognition. The radiologist creates a report by talking into the handheld dictation microphone, and the speech recognition software converts what the radiologist says to text. The typical accuracy of speech recognition software is about 95%, requiring edits to be made. So no matter how good your software is, as you talk to the microphone and it types out your report, you will have to make some edits. It's not going to be perfect. There are 3 possible workflows for reporting. Immediate reporting. The radiologist reviews the report immediately after dictation, makes corrections, and signs it so it can be available for the requesting physician immediately. So it's one at a time. You make a report, you review it, you look at it, you sign it. Batch reporting. A radiologist might dictate a whole batch of exams and then correct them as a batch, which can only be done if there are no urgent cases waiting to be read. This is very common in something like mammography. There's no mammo emergency cases, so you might dictate a whole batch of screening mammos and then go back and look at each report and make the corrections and then just sign them all as a batch. And transcriptionist reporting. Reports are forwarded to a transcriptionist who really works more as a correctionist to perform the corrections. So transcriptionists used to type the reports, but now that we have voice recognition software, they don't do the typing. They'll just look at the report and fix the words that they know are wrong. The handheld dictation microphone will likely have buttons which perform tasks to make reading more efficient. So you can see on the microphone there's a whole bunch of buttons, and you can use it to move forward a field, move backward a field. There's buttons on there that will allow it to work like a mouse, and you can program those function keys at the bottom to do certain things you want them to do. Maybe you want them to insert your favorite macro, maybe you want them to jump forward in a field, whatever you want them to do. Those function buttons, F1, 2, 3, and 4, are programmable. Structured reports are constructed from predetermined templates. So what you see on the screen here is an example of a template for a CT of the cervical spine. And a lot of radiology groups like this so that everybody's report looks the same. My report looks like the other radiologist's report, so we all use the same template. And inside the brackets are the part you would need to dictate. So if you see at the top, you see history, colon brackets, you would have to dictate the history. Anything that's outside the brackets is hard-coded. You don't need to dictate it. So then you would say next field, and that would move the cursor down to comparison. You would dictate the comparison. You would say next field, and that would move you down to the brackets that are next to prevertebral soft tissues. That's how a structured report works. Macros. Macros are blocks of text which are commonly used in most radiology reports and can be dropped into the report currently being read to save time. This reduces the occurrence of mistakes in the text since the macro text has already been proofed. Meaning you've already made this macro and you've made sure it doesn't have any typos in it, so it's ready to go. So there's some other things about macros you need to know. For example, macros can be dropped in by voice command. You can say insert normal chest, right? And so that's way faster than having to dictate all of the elements of a normal chest. You just say insert normal chest and boom, all of the verbiage for normal chest drops in. You can also insert a macro through keyboard. Usually there's some keyboard shortcuts for macros, so you might make your normal chest report something like Alt-C. So you push Alt-C and the normal macro goes in. And lastly, on the report page, at the left side, any macros that match that particular type of study. If you're reading a chest x-ray, all your chest macros will come up. You could just use your mouse and click on it, and that would insert it. So it could be done through voice command, keyboard, or mouse. Macros are really important because they have a bunch of benefits. For example, it's faster than normal report construction. You don't have to constantly dictate, make a normal report. You just say insert normal chest, insert normal hand, insert normal CT of the abdomen. Boom, the whole thing goes in. It provides a basic framework of a diagnostic report with only variables to be populated. So using macros, you can quickly bounce those fields and make that basic framework of a diagnostic report. And honestly, it just makes you faster as a radiologist. You can read more studies during your shift if you use macros rather than having to dictate each report individually. Alright, so I beat the macros to death there. Critical results reporting. A result could be of various degrees of criticality, needing follow-up within an hour or sooner, somewhat critical, requiring follow-up within a day or follow-up in a week or more. The criticality can be encoded with a number or color code to communicate between the radiologist and requesting physician. Basically, every study is not normal. Most studies are normal, but some have, oh my God, this person has cancer, a big cancer nodule in their lung. They need to get seen tomorrow and get on a treatment plan. So when the radiologist sees something that's critical, he can mark that as critical with a color code. This is a stat report. This is a red report. This is a blue report. There's a lot of different ways that hospitals use to code them with numbers or colors, but critical results have to get to the requesting physician immediately so that patient can get follow-up. Discrepancy reporting. Discrepancy reporting is when there is a difference between the preliminary diagnosis, such as done by an ER physician, and the diagnosis by a specialist radiologist. So, if you come into the hospital in the middle of the night and you get your hand x-rayed, they're not going to wake up the radiologist to look at your hand x-ray. The ER physician will look at your x-ray and he will make a preliminary report saying, I think the first metacarpal is fractured somewhere near the head. It's going to be preliminary and basic. Maybe he doesn't pick up the other fracture in the fifth carpal bone or whatever it is. So discrepancy reporting is when the ER makes a preliminary and the radiologist says, well, you saw this, but there's these other things, or this isn't what you thought it was. So that's a discrepancy report. And finally, peer reviews. Quality control procedures require often a regular peer review whereby colleague physicians will review a report or result. And potential discrepancies can be analyzed and used as input to improve the quality of the reporting. Basically, that means one radiologist checks another's work. So I read 100 studies yesterday, and you come in and you're going to read 5 to 10 of mine to make sure that I got the right results, that I saw the correct things in the images, I didn't miss anything. You're going to double check my work, and that happens on a regular basis where one radiologist will check the work of another radiologist to make sure that he's catching everything that he should catch, because these are life-changing reports. They're talking about whether a person has cancer or not, whether they have tuberculosis or not, whether they have broken bones. So treatment is based off those reports. It's important that they get them 100% right, and that's why they do peer review. Thank you for watching.